So, it's been a while actually, 24 hours to be exact, and I haven't touched any question. Um, let's continue with where we left it. Yeah, so I did balanced binary tree, then I'm thinking of doing this linked list cycle. So, this question, given a head of a linked list in mind, if the linked list has cycle in it, there is a cycle in a linked list. If there's a node, okay, if there's a node in the list, then can be reached again by continuously following the next pointer internally. So, in the next pointer internally is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as parameter. So basically tail will be connected to some internal node. This is what I'm getting from it. So it will be a loop. So how many ways can we detect a loop? Let's see. Hash table linked list 2 pointers. 2 pointers solution I already know. The math behind it we will discuss later. Hash table I don't know, because I can try with hash table. Yep. So I can start with address of a node and its next address in a hash table. Okay. So or 2 will be having in degree as 2, right, in this point. So we need to calculate in degree of each node. So what can we do? If there's a loop, right, in a linked list, then there's a single node which has an in degree of 2. So to do that, actually you need to, if I do DFS on this, right, so I'll start from 3. Suppose this is a graph, so I'll start from 3, next 2, next 0, and I will set visited as true, true, and true, and then I'll also again visit 2 again, right? So as visit is true is already there, I will declare that is the position. I mean, we are not keeping the position actually, so we'll at least get the node, right, and we'll just match the node in next iteration maybe. Okay, so let's do it with DFS maybe. List node equals degree, and we'll pass head, and if node, and this is a null, then we will return false. And I'm just making this little complex, I believe. I'll do this. I'll do here degree, and this will be a list node. This node head, return type will also be ptr. Here we'll put the code, and what should the code? Comma. Let's bool visited बराबर false. I mean false, and this will not work. Yeah, I'll exercise this in no tablet session. I'll keep this DFS to find loop linked list, and yeah. Now, what will the hash table approach? Let's see. We will keep the node, then its position, node and position, 3 at 1, 2 at, so then 3 next is 2, and we'll check if the node already exists or not. Yeah, correct. Map unordered map and list node star and pos int, that will be position and map, I mean only, and I cannot do auto in this one, right? So while I'll do list node head, and while this I'll try, I mean there will be a loop in this clearly, right? And I can return false if there's no loop, and if there's a loop, obviously we'll detect inside this loop and we can return it, right? So yeah, here we can write the logic like m dot find, if m dot find if m dot find is not equals to m dot end, that means it has it, right? And we can just return and return m of this, that's it. And what else we can do? Yeah, if it is not there, we will just add it to the map. M of cur equals wait, int I equals 0, and we'll do I plus plus. This I believe we can trust. Let's see. Wrong answer. Return false. This case also false. Those should have an We are not returning mcar, bro. Yeah, we will be returning this only. Also, I'm not actually iterating occur to next question, right? Occur should be equals to occur of next. Yeah. This one is true. False equals 1. And this one is also. So this one is false. Yeah, couldn't find it. This one should have been true. You say. So we have this, and false can be returned only from here. So m dot cur. Okay. Actually, this one is asking just to return true or false. What the hell? True. False. True. False. Let's run it. Yeah, that's more like it. Try to submit it. Yep. So there's one 2-pointer solution which actually works like fast and slow pointer, and when they match, then you return the solution. I can write that solution as well. I need to keep in mind check maths behind fast and slow pointer of above. Yeah, that we will also do. Now let's try to do or implement that fast and slow pointer solution. So I mean there will be a list node. I'll make it fast and other one will be slow equals fast. So while slow slow is not equals to fast, slow equals slow next, and wait, you can do while slow, right? While slow, and we'll be checking fast, like if there's no loop. Understand? So I need to check fast in that case, not slow. While fast, and fast equals fast next. Also, I need to check if fast next is possible, and at some point of time I can also do this and then slow. Yeah, at some point of time we will get if fast equals slow, we will just return, right, true, and I believe this should work. So in this case this is not working. We are returning So fast is going to be slow actually. So I guess we need to after doing the iteration only we should try to find out. I believe. Yeah, my bad. Now, yeah, now I guess all the guesses are passing, and we can check. Okay, there's one wrong answer. Case number 25 out of 29. I believe this one is mostly right. Let's see. To find loop in linked list. Okay. It is checking a fast and fast next. Okay, I'll try this one. So done this, done that. If use this test case. Now if fast, what was different in that case? We are doing this right, correct, and fast next. It has extra added as whatever I can with my observation what I've made. Fast and fast next. Let's see. Okay, so I guess the test case is giving some problem. Okay, fast and fast next. This is the only thing which I have noticed, right? Fast and fast next. Slow is moving fine. Fast is moving fine, and we can remove this check. And if fast equals slow, return true. Yeah, correct. Else return false. I believe so. This should run. What is this unknown error? Yeah, it worked. Solution is slow and fast node like this, and it worked. All right. So we'll do the maths behind it, right? Later on. Another question down. Next question, implementing queue using stack. So this question is something that I'll pass. Get my point. I don't like this kind of questions at all. What is the topic? Stack design queue. All right, I'll try. So what they want is push element X to the back of the queue. remove element from the front of the queue. Implement queue using stacks. Return true if the queue is empty. Return false otherwise. So we'll be having this class myQueue. I will do this in Java. So we'll be having this constructor, you can say. Inside constructor we can have one initialization which we can use to put things right. So I guess I can leave this one. First bad version. Let's see. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Okay, since each version is deployed based on previous version, all version after a bad version are also bad. Suppose you have n versions, 1 to n, and you want to find out first bad one, which causes, okay, you're given API bool is bad version, return where the version is bad, function to find the bad version is the number of API calls. I guess this can be a binary search question in that case, right? Because the versions are in a sequence. So, sure, I'll try. So, int mid. Let's take left and right. L equals 0, R equals n, right? And yeah, while L is less than n. While L is less than n, I have already done one binary search question, right? So let me check that first. Submission. Wait, this one is recursive. Okay. And this one should be the iterative, right? Yeah. L is less than equals to N, not N but R, into mid equals see, int mid, we will be calculating int mid, that will be L plus R, so R minus L. By 2. This will cause an overflow, binary search overflow thing. Wait. So suppose we have highest 10, lowest 5, so 10 plus, no, highest 10 and highest 20 and lowest 10. So 10 plus 2, 10 plus 20 by 2 equals 50. Now we have this 20 minus 10 is 10, right? Then 20 minus 10 by 2 equals 5, 5 plus 10 equals 15. Yep. Our flow and behavior is undefined. Is my audio working? Yeah. Simple way is just the add the difference between them, but just half of it to the smaller value. It is like we are looking at two trees. One is 200 feet tall, another one is 210 feet tall. What is the midpoint or mean? We don't have to add them together first. We can just tell the difference is 10 feet and we can add half of that. We can add half of that, which is 5 to 200, and no, it is 205 feet. So there's two numbers. There are two numbers and we want to find the median. to this into perspective, mentioned that first binary search was stated wasn't correct until 90% of personal program could not write it correctly when for okay. I always wanted to understand this one, okay, so this is why I'm taking my time. And I got the point actually, but I need to this overflow thing I got. Okay. This is what exactly I wanted. L by 2, R by 2, L by 2 plus R by 2 plus 0 equals this. Then we can do, okay, L by 2 minus L by 2 and L by 2 plus 1 L by 2 and 1 L by 2 minus 1 R by 2, and we can say L plus R. Okay, mathematically it is also correct. I could have done this on pen and paper. I like this. I can upload this one. Yep, nice one. Yeah, so let's do that then. R minus L plus L, and now we have found midpoint. Now if mid equals true, if mid equals true, we are not yet sure that the next one will be the first bad version or not, right? So you can do it bad version, right? Is bad version of mid. Yeah, it bad version of mid is bad version of mid. What should I do in this case? I believe this will be a very small answer if I can do it correctly. So we want to find out the first true value, right? That means 4 is the first bad version it is seen. Anything in discussion? I hope this guy's trolling. Uh, I'm a little confused. Like, if in the first try or any try, suppose this is the place where I will be finding the answer, right? So at any point of time, if I find the answer, I actually need to check, right, if left of it or right of it is still true or not. If it is false, we know mm, that this is not the answer. So, uh, if it is, yeah, at least what I can do is uh, I'll do that first. What I can do? So it equals false. Suppose then my R will be mid -1, right? Else there can only be two things. Yeah, right. I guess I got it. Else, wait. Return true, and in this I mean false, and else not false. I can return 0, right? Because I couldn't find any false, maybe. Or even I couldn't find any true, maybe that can be also. We'll see. 0 means false only, by the way. Anyhow, else. What will I put in else is? Means it is true, and is if is bad version mid +1 equals false. See, coming to this else means it is true, and then +1 equals false. Then I can return mid. Else, if it is already true, right? If it was already, again, this one was also true, means what we can do is left side will be mid +2. Yeah, maybe this will work. Put 0 expected. Output is again 0. Why this one is not working? I'll see the solution. binary search. If this one is false, then we are making r equals mid. Okay, else so it is coming inside calculating the mid. Let's calculate it normally. Oh, this is fine. The way of calculation is fine. L plus r minus 1 equals 2. Though I guess if we got this right, then r will be mid minus 1. And if we got this one is mid plus 1 false, that means it before this was true, so we are returning mid. Else we are doing else l equals to mid plus 1 here, and we can return as per this, let's say. But this one is always returning 0. How can it be possible? If this guy is true, if this is true, we are making r equals mid. Else we are making l equals mid plus 1. Okay, I'll add this question to analysis as well. I guess it will not take much time. First bad version. Alright, what is the next question here? I need to start that course as well, which I talked about. So yeah, that is also remaining. Ransom note. What is in this ransom note? Given two strings, ransom note in magazine, return true if ransom note can be constructed using letters from magazine. False otherwise. Is there any thing? No. So given ransom note, that is A, magazine has B, false. Ransom note AA, magazine has AB, false. Ransom note AA, magazine has this AAB, true. Alright. Okay. This comma 0 and ransom note, right? So ransom note. Okay. Ransom note, or we'll do the magazine first, or maybe we'll do the ransom note first. Okay, and I'll paste it here. And what we'll do is ARR of C minus A plus plus. So we got the ransom notes. Minus would be fine, but there should not be any positive values. We should look out for positive value. The third loop, this will be magazine. Minus minus. Also only if ARR of C is not equals to 0. Now, in that case only I'll reduce. So in that case I'll not reduce it further more than 0. And yeah, for turn true for int x in ARR if zeros should come, right? All of them should be zeros. So x not if it is any of the values is other than 0, we will returning false. Let's see. Now just C minus A. Yeah. Okay, many of the values can be this, right? So how will you determine? Okay, I can make -1. Mm-hmm. Mm-hmm. Yeah, this will be a little confusing. Let me just think. For a while, we got this letter. We got this letter and we added it, incremented its value, then we reduced its value, and while if the value is other than 0, right, the value is other than 0, then we'll return false. Yeah, this is why I need to speak. The fuck. Yeah, it is working and working okay-ish. Let's check out other question. Climbing stairs. Topics. Alright, dynamic programming is there. Each time you can either climb 1 or 2 steps. Is in how many distinct way you can climb up to the top. This solution I have done before. I can maybe use the same method. Not I'm trying to say the same method, but same idea if I can come up with. I guess, have I submitted it before? No, actually. Maybe I've done this problem somewhere else. On Geek for Geeks or somewhere, I guess, in college time. I do remember this problem. This is more like that Fibonacci something type of problem it is. So let's have see. There's a step, and let's suppose first you use the first step, right? Suppose you first option will be 1 only. Okay, so I think, right? So int a equals 1, and second option will be if you want to go to the step 2, either you can use the int a or you can use the int b. That means 2 step at a time, right? So you are reaching the second step. So see, if there are 2 steps, the number of ways are 2, 1 plus 1 and 2. If there are 3 steps, number of ways are 1 plus 1 plus 1, 1 plus 2 and 2 plus 1. So So we can see to get to the step 2 we have two ways, and those two ways are going to be 1 plus 1 and then 2 steps, right? Now to climb up to the top, if there's 3 steps, we have 3 ways. So out of those 3 ways, how many are common to the 2 ways? So first one is we can go 1 plus 1 plus 1 means we'll do at least this. Okay, I'm a little confused in this one. Let me think. If there's one step, I can only climb it one way. That is 1. If there's 2 steps, either I can do 1 plus 1 again 1. So means suppose I'm already at step 1, right? If I see, this will be I'm already step 1. Now what I can do, I want to go to the step 3, right? So sorry, I'm already step 2. What I can do to get to the step 3, plus 1 here, right? Again, I'm already at step 2. What I can do, the way I've reached is by 2 steps, right? So this is the one solution, this is the one solution. What I can do, plus 1. Now there is one other solution. Like if you were at step 1, and to reach step 1 there was only one way, so we will write down 1 here, right, like this. And if you are step 1, what are all the steps you can take to reach 2 steps above? That will be 2. The answer is already there. So like that, maybe we can do this. So yeah, maybe I'll need a linear for int I equals 0. I should be less than n. I guess we can make a standard formula out of this, I believe, as well. Let's make a formula out of this. Suppose we are at step x, then we can go to x plus 1 by x plus 1 way. Suppose we are at x and we want to go to x plus 2, then we can go to step 2 by x plus 2 ways. And we are at step x and we want to go to step 3, we can go x plus 3 ways. So if you are at step 3, how many ways in total you can reach step 3? Or if you are at step 5, how many ways can you reach step 5? That is the question. Maybe you can say let me think. Int answer equals a plus b. Second, and say we are already at step. We are already step 2. 3, I mean. So yeah, suppose you are at step 4, so 1 plus 1 plus 1 plus 1, that will be one way. Then 1 plus 2 plus 2, no, 1 plus 2 plus 1, that will be another way. Then 2 plus 1 plus 1, that will be another way. Then 1 plus 2 plus, I mean 2 is there, 2 is there, 2 will be in the end, so 1 plus 1 plus 2, that will be another way. So 4, and fifth will be 2 plus 2, fifth will be 2 plus 2, so we'll have 5. So suppose we are already at 3, okay, and how we are going to calculate the fifth step is we can do in a plus equals 1 or a plus plus, okay, b plus equals a, answer plus equals a plus b, and return answer. I have not applied my mind, that's why I don't know why I have written this. Let's see what happens. Wrong answer. In this case, this is correct. Let me add one test case for the 4 steps. What is the answer? Expected is 5. I am outputting 9. Outputting 6. All right. We'll do this on tablet, I guess. This one as well. I'll stop the video, it is already too long.